Okay, in this video, I want to talk about something which sounds a little bit abstract and intimidating, but actually is pretty simple when you really break it down. It's called moment of inertia. So I think the easiest way to start here is kind of with an analogy. Um, in the first part of the course with F equals ma, mass is a quantity which determined how much an object resists changing its motion, and therefore determines how heavy an object feels when you try to move it. Okay, so that's what mass kind of is at like a really kind of basic level. It's how much an object resists changing its motion. So like, let's say an object is stationary and you try to get it started moving. If the object has high mass, it's going to take a lot of force to get it moving. If the object has lower mass, it's much easier to get it moving. So when you get into the world of rotation, is this still the case? It's a very similar idea, but in the physics of rotational motion, moment of inertia plays this role. So moment of inertia tells you how much an object resists changing its state of rotational motion. So for example, if I take this pen here and I want to rotate the pen like this, I can feel how heavy that is with my finger. If I do the same thing with this hammer and I try to rotate this, the hammer feels heavier. Why? I mean, you might think it's just because the hammer is heavier, it has more mass, and that's part of the reason, but really the most, direct reason is because of the difference in moment of inertia. What makes moment of inertia a little bit confusing is that moment of inertia depends on a number of different things. So moment of inertia depends on, first of all, it does depend on the object's mass. So, it is true that because the hammer has more mass, that's part of the reason why it has a higher moment of inertia. So that part's pretty obvious, but by no means is that the only thing, or sometimes even the most important thing in determining the moment of inertia. The object's size and shape also factor into the moment of inertia. So if you take two objects with exactly the same mass, but their shape is different, like for instance, say you take one, long rod, and then you take one rod that has exactly the same mass, but it's like short and stout kind of, they'll have a different moment of inertia when you try to rotate them. Or let's say you take, a hollow cylinder versus a solid cylinder that have the same mass. They'll rotate in a different way. They'll have a different physics for their rotation. So you have to know how big is the object. By the shape, I mean, like, is it, a cylinder, or is it a sphere, or what is the shape of it? And also another aspect of that is, where is the mass located on the object? So for instance, a cylinder that has its mass uniformly distributed throughout has a different moment of inertia from a cylinder that has all of its mass concentrated on the edge, like a hollow cylinder, like I was saying. So you have to know where the mass actually is on the object. And most confusing of all, you have to know where is the axis of rotation for the center of the rotation. Now this one is confusing, but it's also one of the easiest ones to demonstrate. And you can do it right now while you're watching this video. Grab a pen, and I want you to try a little experiment here. grab the pen by the center and try rotating it like this, and just get a feel for how that feels. Now take the exact same pen and just hold it by the end, and now rotate it like that. And you'll find it feels completely different. When you rotate it like this, it feels much heavier. If you go back to the center again, this feels very lightweight by comparison. Again, the weight is no different, the mass is no different. What changed was the moment of inertia, because the moment of inertia depends on, when we say the axis of rotation, we mean basically the center of where the object is rotating around. So when you rotate like this, the axis of rotation is going through the center of the object. When you rotate it like this, the axis of rotation is going through the end of the object. And same thing goes for the hammer. If I swing the hammer like this, it feels quite heavy. If I grab the hammer by its center of mass, which is about here, and rotate it like that, it feels much lighter. So that makes a big difference. Where is the axis of rotation on the object? So as a result, you can see that moment of inertia is affected by lots of different things. So as a result, it's going to be a little bit of a chore trying to figure out what is the moment of inertia for a given object. You know, when it comes to mass, that was just like, oh, there's a 5 kg object, done. When it comes to moment of inertia, there's actually going to be a whole side thought process that you have to go through to figure out how much inertia the object has before you can even really get started on thinking about the physics. So I think maybe I'll stop here and do a separate video about how to actually think about the moment of inertia on a particular object.